Okay, I am going to do this math problem for you. And so I have the problem is you are required to administer 500 milliliters of normal saline over 3.5 hours. The drop factor is 10. How many drops per minute are required to start the flow off at the correct rate? So what I like to do as far as starting this problem off is to write down my information. So in this case, I'm going to put the information. You are required to administer 500 milliliters. So I'm going to put 500 milliliters over here of normal saline over 3.5 hours. So I call this a sentence. And when we are doing our dimensional analysis, you can't pick and choose where your sentences go, so you want to write them in this format. Okay, then the next information that is on here is the drop factor is 10. So in this case, our drop factors are written in drops per milliliter. And in this case, we have 10 drops per milliliter. So that's information we have for this problem. And we're wanting to solve for how many drops per minute. So we want to know how many drops per minute to solve this problem. Okay? So with dimensional analysis, it can be used in any and all the problems that you come across in Math for Nurses. And it's very easy, and you don't have to remember any equations. So with dimensional analysis, in this case, since we have drops on top and minutes on bottom, that's what we're going to be solving for. So I'm going to start out my equation with something that has drops in it. And on down the line here, I'm going to go ahead and put it kind of way down here. I'm going to put over minutes. So ultimately, we want to start with drops, end in minutes. And then of our information here that we've written down, or known variable equations that you also may have to add in. We'll get into those as we come across one. So first thing, we'll go back to what we want to start with. And in this case, it's drops. So we go back to our sentences. Here I have one sentence, two sentences, and the sentence that has drops in it is 10. So this says 10 drops per milliliter. So I'm going to plug in this 10 drops per 1 ml. Okay? So now we've gotten that sentence out of the way. Well, if this is milliliters, we have to have milliliters here to be sure that we can cancel out our milliliters, and ultimately that's what dimensional analysis is writing down all of your information, then knocking things out that you don't need as far as our descriptors go, and then solving the problem. So now we've written milliliters, so now we're going to go back up to our sentences and find something that has milliliters in it. In this case, we have 500 milliliters over 3.5 hours. So that's what I'm going to put here, 500 milliliters over 3.5 hours. Now, this is in hours. We want minutes, so we are not done with this equation. So with that being said, if we have hours here, we have to have hours here. Well, if you go back up, because we've used this now, if you go back up and look, you'll notice that we don't have any hours left. This is where you have to go to those known variables. And since we're wanting to go to minutes, I want to go from hours to minutes. So with that being said, what do we know about hours to minutes? Well, we know that 1 hour is equivalent to 60 minutes. Right? So that is where we will be able to stop since we're solving for drops per minute. So I'm going to go ahead and get rid of this because I made my line too long, so that doesn't confuse you. And so now as we go through here, we can cancel out milliliters and we can cancel out hours. And that's going to leave us with these numbers times these numbers, but ultimately giving us drops per minute. So now let's do the math across. We have 10 times 500, and that gives us 5,000 over 60 times 3.5, and that gives us 210. So then we're going to do 5,000 divided by 210, which gives us 23.8, and I'm going to go ahead and round that up because anything over your round of 5 is going to be greater than, so I'm going to put 24 drops per minute. And then that would be our final answer.